Okay, here we are. We are back again. Last couple of examples. So here is, there we go. This is example 6 in the textbook. X squared plus 4 squared dx. Okay, function to an exponent. Okay, I know this. This is easy. U equals x squared plus 4, right? And du, of course, will take the derivative. Derivative of 2x, or x squared is 2x. Derivative of 4 is 0. Boom, there we go. So, do I have the 2x dx? Got the dx. I could get a 2 by putting a 1/2 out here, but I don't have the x. And this means this rule, the power rule, is not going to work on this at all. And the only way you have to integrate this is to expand it. So I'll take this thing, x squared plus 4 squared dx, and I'm going to write it as x squared plus 4 times x squared plus 4 dx, and I'll use my little friend. So x to the 4th plus 4x squared plus 4x squared plus 16. And we'll combine the two middle terms, the cross terms. Okay. Now we can do this individually, because x to the 4th, we can do the integral of that. We did that in the last section. So this will be x to the 5th over 5 plus 8 times derivative of x squared would be x, or the integral, x cubed over 3. And the integral of 16 will be 16x, because this is x to the 0 power. 0 plus 1 is 1. So sometimes it looks like it's a power rule function, but you don't have enough goodies there to get your differential du here so that you can apply the rule. And when that happens, you got to just multiply that dude out and do it term by term. And that's not fun, but that's the way it goes. Well, that's not true. It is fun, of course, because calculus is fun. Now, let's see. Next one. This is example 7. So 2x squared minus 4x to the 7th times x minus 1. You're probably thinking, holy crap, this looks a whole lot different than the others, and it is not. It is the same. It is a function raised to an exponent. And we just do it the same way. Let u equal 2x squared minus 4x, and then du, the derivative of 2x, 2 times 2 is 4, so 4x minus 4 dx. Now let's go and see, do we have 4x minus 4 dx? No, we have x minus 1. Well, that's really darn close, isn't it? If we could multiply it by a 4, 4 times x minus 1 will give me 4x minus 4, right? So by getting that constant in there, so 2x squared minus 4x to the 7th, and here's my 4, and I'll multiply this in there. So that's 4x minus 4 dx. So here's my u to the 7th, and here's my du. So that's going to be, we got to keep that 1/4 out there. U to the 8th over 8. And now let's plug in our u, which is this guy, right? So that will be, oops, I kind of went the wrong way. We're going to stick it in down there. 2x squared minus 4x to the 8th over 8. And obviously you would combine those and make it 32, right? Does that make sense? What's the trick? The trick is this right here, right? Showing these steps so that you show what u is and what du is, and then you multiplied by some constants to force the right coefficients here. It's a very common trick. Okay, I think there's one more. Yes, it is. And it's a fun one. It is a marginal revenue. And recall, marginal revenue is the derivative of the revenue function. And if I take the integral of a derivative, I'm going to get back the original function. I don't care what letter you use, R or F or Q or whatever. So if this was the marginal profit and I integrated the marginal profit, it will tell me the profit. Doesn't matter which function it is, this works. You take the integral of a derivative, you get the original function. And example 8 says the marginal revenue, and they write it this way, they don't write it like that to be sneaky, is 600 over square root of 3x plus 1 plus 2. And we want to know what is the revenue. So that means we need to take the derivative of the revenue, we need to take the marginal revenue and integrate it to find the revenue. So I'm going to take the integral of, we'll write it as 600 times 3x plus 1 to the negative 1/2. 1/2 because it's a square root, negative because it's in the denominator, plus 2 dx. Well, I see here's a function to an exponent, but here it's just a 2. So I think it's probably best that we break this up. So our revenue function is going to be the integral of, and I'll pull the 600 out front as well. I like having the coefficients out in front there. So 3x plus 1 to the negative 1/2 dx plus the integral of 2 dx. And what's the integral of 2 dx going to be? Well, this is 2 times x to the 0. X to the n plus 1 over n plus 1, that's going to give us a 2x. 2x to the first over 1. Okay? So we're going to do that to this one, but let's focus on this one here. The first half. Let u equals 3x plus 1. Then du is going to be 3 dx. Derivative of 3x is 3. Derivative of 1 is 0. Okay, do we have a 3 dx? No, we got a dx. So if I put a 3 in here, I'm going to have to put a 1/3 in front of that thing. So 1/3 times 300 is 200. Integral of 3x plus 1 to the negative 1/2 times 3 dx. And I'll go ahead and write this as 2x and the integration constant that came from integrating 2. And whatever integration constant we get from here, it's going to get all clumped into there. So we don't need 2 integration constants. So here's 200 times u to the minus 1/2 times du. So this will be 200 times u to the negative 1/2 plus 1 is positive 1/2. Positive 1/2 down here will flip and become a 2. And u is this thing, 3x plus 1. We got some little bit of simplification and make that 400, right? But there's how we're gonna find the revenue function for this marginal revenue right here. We took the marginal revenue, which is the same as the derivative of the revenue. And when you integrate the derivative, you get back the original function again. So we put the marginal revenue inside an integral, integrated over dx, the number of units we're selling. And then we go ahead and did the integration. And I know when I look at this function here, when I sell 0 units, how much revenue should I get? 0, right? So if I plug in 0 for x, I know the revenue is going to be 0, and that's going to enable us to find the constant here, which I don't think you have to do that. I don't remember. You might, but if you have to do that, you're going to set that revenue function equal to 0, because that's a known value. 0 units sold means 0 revenue, and then you can solve for the integration constant. And I think that's all she wrote. So give these a try and make sure you ask questions. If you need help and you can't do office hours, email me and ask me for a time when you can do it. And I bet I can accommodate you right now, and I can help you at some other time other than office hours. So let me know if you have any trouble. Watch all the videos, do the homework, and have fun. And we'll see you hopefully at office hours. Bye.